Now we're going to conduct the test of independence for a specific example. When you're being asked to conduct a test of independence, I recommend that you use Google Sheets. Okay? I understand that you might not have access to Excel on your computer. Maybe you don't have Excel downloaded into your computer, which is why I always refer to Google Sheets. On Google, you can create a free account and you can access a Google Sheet anytime, anywhere with any computer. So be ready with that. You're going to see that Google Sheets is going to be really helpful for organizing all the values that we're going to have for the expected values and the values we get when we take O minus E squared divided by E. Let's look at this example. In a volunteer group, adults 21 and older volunteer for 1 to 9 hours each week to spend time with disabled senior citizens. The program recruits among community college students, four-year college students, and non-students. The table below is a sample of all adult volunteers and the number of hours they volunteer per week. Now, we're being asked to conduct a test at a 0.05 level of significance to determine if the number of hours volunteered is independent of the type of volunteer. So notice, we're saying, is this variable, the number of hours volunteered, is that variable independent from the type of volunteer, from this other variable that we have? So the contingency table here has data coming from a sample. We see that the sample size is 839. Here we see one of the variables, which is the type of volunteer. And notice we have 3 different categories for that variable. We have the category community college students, the category 4-year college students, and the category non-students. Let's go ahead and make a note of that. We're going to write, there is 3 categories. Now, if we look at the columns, we see the other variable, I'm just going to say variable number 2, which is the number of hours volunteered. Okay? And notice we have 3 categories, 1 to 3 hours, that's one category, 4 to 6 hours, that's another category, and then the last category is 7 to 9 hours. Okay? So this variable also has 3 categories. Now, how do we know that we need to run a test of independence? Well, it's asking us, is this variable, the number of hours volunteered, independent from this other variable? Okay? So this is the reason why we need to run a test of independence. We are wondering if a variable is independent to another variable. So let's go ahead and write the null hypothesis. Our first step in this test is going to write the null hypothesis and the alternative hypothesis. For the null hypothesis, we're going to write that the variables are independent. So I'm going to write the number of hours volunteer is independent of the type of volunteer. For the alternative hypothesis, it's going to be the opposite. We're going to write the number of hours volunteer is dependent of the type of volunteers. We're going to be running the test of independence to determine if we find enough evidence coming from this sample, okay, to conclude the alternative hypothesis. One more thing to know here is that we're going to be using alpha equal to 0.05 as the level of significance, okay? We're going to be comparing our p-value to this level of significance to make a decision of whether we're rejecting or failing to reject the null hypothesis. So let's go ahead and move on to the next step. The next step is to find the test statistic. This step is going to be very time consuming. It's going to require you to stay really organized. Here in this activity, I provided some space and tables for you to do this by hand, to find each of the expected values here on your activity. I provided space for you to find O minus E squared divided by E for each of the cells. But the way I'm going to be doing this is by using Google Sheets, because that is going to help us work a lot faster. Notice here we have the original table. Then here below we have a table where we're going to be finding the expected value for each of the cells. And for the expected value, we need to take the row total times the column total divided by the total of individuals. Once you have the expected values, you can go ahead and compute O minus E squared divided by E for each of the cells. Once you compute O minus E squared divided by E for each of the cells, then you're going to add all those values, and the sum of all those values is going to be your test statistic. Okay, so again, you can do this by hand, relying on paper, on your notes, and on your calculator, but I'm going to be doing this using Google Sheets. So here's what I'm going to do. I'm going to copy the original table. On Google Sheets, I'm going to go ahead and paste the table. So this is the original table. Now, I'm going to create another table. I'm going to copy and paste this table. But the table below is going to have the expected values. On that table, we're going to take the row total times the column total divided by, I'm just going to write sample size, or the total number of individuals, right? So that is what we're doing on the table here below, finding the expected value. So let me go ahead and copy this table. I'm going to paste the table here, and I'm going to delete all the values that we have inside the table. Now, I'm also going to delete the total column. We don't need that. And I'm also going to delete the total row. Okay, we don't need those. We're only finding the expected values for each of the categories. We're not finding the expected value for the total column and the total row. Okay. Let me go ahead and take off the border lines. And so let me edit those border lines. That's going to bother me since we're not using the total row. We don't need those here. I'm also going to do the same with the last row that I deleted. So this looks a little bit nicer. Again, we're going to be finding the expected value for each of these cells. Okay, so starting with the first cell, the number of college students that volunteer for 1 to 3 hours. How many students are we expecting to see? For this cell, we have a row total of 255 and a column total of 998. So we need to take those values and we need to multiply them. So we're going to type equal, click on 255, multiply by 298, go ahead and click on 298, and now we're going to divide it by 839. You can click on 839 instead of writing 839. Now click enter, and there you have it. That is the expected value for the first cell. Now let's go ahead and move on to another cell, the cell to the right. How many students are you expecting to be community college students and volunteer 4 to 6 hours? Well, we're going to type in equal. We're going to click on the row total, which is 255. Then we're going to multiply by the column total, which in this case is 379. So go ahead and click on that value. Then we're going to divide by the sample size, the total number of people that we have, which is 839. So click on 839, press enter, and there you have it. That's your expected value for that cell. Let's do the rest of them. For the next column to the right, the expected value for community college students who volunteer 7 to 9 hours. The expected value would be equal to 255 times the column total, 162, divided by the sample size, 839. Press enter. You can fast forward the video if you get the idea. You can do the rest of them, but I'm going to go ahead and go into details about how I'm doing each of the expected values. For the next cell, 4-year college students who volunteer 1 to 3 hours, we have equal row total, 290, times column total, 298, divided by 839. The next cell to the right, we have a row total of 290 times a column total equal to 379 divided by the sample size, 839. Click enter and you have the expected value. The next cell to the right, we have a column total of 290 times a column total equal to 162 divided by the sample size, 839. 3 more left, starting with the expected value for non-students who volunteer 1 to 3 hours. We're going to type equal. We're going to take the row total, 294, times the column total, 298, divided by the sample size, 839. Press enter, and there you have it. That's the expected value. The next cell to the right, we have equal to 294 times 379 divided by 839. And the last one, again, row total, 294 times 169, which is the column total, divided by the sample size, 839. Okay? Now you have all the expected values. Notice it's much faster with Google Sheets. You don't have to be writing all those values and all the values after the decimal on your notes. You can go ahead and just do it here. And then you can go ahead and take a screenshot or copy and paste these values into your notes. Now that we have the expected values, we can go ahead and find O minus E squared divided by E. So for this, we need to create another table. I'm just going to go ahead and copy the table, the second table we have. And I'm going to delete all the values that we had inside the table. Because now the values that we need to compute are O minus E squared divided by E. Okay? So let's start with the first cell. We're going to compute O minus E squared divided by E for community college students in 1 to 3 hours. Okay? On the cell, we're going to type the equal sign. You're going to open a parenthesis. Then you're going to click on the observed value for this cell. The observed value comes from the original table. The observed value for this cell is 111. So click on 111, then subtract by the expected value. The expected value for this cell is 90.57210.965. Click on that value. Now close the parentheses. Use a caret to indicate that you want to take this expression to the power of 2. So notice here we have equal O minus E squared. Now we're going to be dividing by the value of the expected value. So I'm going to click on the expected value again. Go ahead and press enter. And there you have it. This is the value of O minus E squared divided by E for that first cell. Now let's go ahead and do the cell to the right. We're going to type in equal, open a parenthesis. You're going to take the observed value, 96, minus the expected value. So go ahead and click on the expected value for this cell, which is 115.190732. Raise that expression to the power of 2. And now divide by the value of the expected value. Go ahead and click on the expected value. Press enter. And there you have it. You have the value of O minus E squared divided by E for that cell. Okay. Go ahead and do the rest of the cells. Okay. At some point, Google Sheets is going to guess what you're trying to do. Sometimes it doesn't guess correctly though. Always double check to see if the suggestion Google Sheet is giving you is the correct expression. So let me go ahead and double check here. It says, do you want to take D2 minus D10 to the power of 2 divided by D10? Well, let me go ahead and look at those values. D2 is the observed value for that cell, so that is correct, minus D10, that is the expected value for that cell. I do want to take that expression to the power of 2, and then I do want to divide by D10, which is the expected value. So this is correct. I'm going to click on that suggestion, and there you have it. That is your value for O minus E squared divided by E. Okay. Again, be careful because sometimes Google Sheets doesn't give you the right suggestion. Now let's go ahead and do the second row, starting with four-year college students in 1 to 3 hours of volunteering time. We're going to type equal, open in parentheses. Let's click on the observed value for that cell, 96, minus the expected value, 103.0035757. Take that expression to the power of 2, divided by the expected value. So go ahead and click on the expected value again. Press enter, and there you have it. Now, go ahead and try to do the last 5 cells on your own. I'm going to be displaying the values that I'm getting here, but I want you to try and do this on your own. There you have them. You can go ahead and compare the values that you're getting with the values I have here on the screen. It might be the case that you need to adjust the length of your columns. So here on the top where you see A, B, C, D, E, F, and so on, you can go ahead and make the columns wider. Now, I do recommend for you to go back and check. I would recommend for you to click on each of the expected values and double check that you did take the correct row total and column total for each of those cells. Okay, so again, I would go ahead and double click on each of those values to ensure that we did click on the correct values. Same thing with the values that you have here on the last table. To make sure that you did click on the correct observed value and expected value. So again, double click on each of them, go through each of them to make sure that you have the correct values. Okay. Now, you are now ready to find the test statistic, which is your chi-square value. This chi-square value is going to be the value that you get when you add all the values on this last table. On an empty cell, I'm going to type equal SUM, which stands for sum, and I'm going to open a parenthesis, and then I'm going to highlight all the values that we have on the last table. I'm going to close the parenthesis, press enter, and there you have it. This is your test statistic. It is possible to do this on your notes. It is easier to use Google Sheets because you don't have to be keeping track of all the values after the decimal. Remember, we should never be rounding throughout this process. We're only going to round until we get to our final answer, which in this case is the p-value. Once we get the p-value, we can round. But before that, we cannot round, okay? So go ahead and take a note of our test statistic. We need that value to find the p-value. So going back to our notes, again, our p-value is 12.99091851. That is going to be the value that we use to find the p-value. Okay? Now, at this point, I'm confident that you can finish the test because the last 3 steps that we have here are similar to the steps we take when we're conducting the goodness of fit test. So I'm actually going to let you do this on your own. And let me just help you visualize this. You're wanting to find the area to the right of your test statistic. Here, your test statistic, I'm just going to write chi-square, is equal to the value that we found above, 12.99011851. Remember, you don't want to round here. You're trying to find the area between your test statistic and a really large value, 1E99. Now, on the first page of this activity, I presented these functions here for the calculator, Google Sheets, and Excel. These functions are going to help you find your test statistic. To use these functions, you need to have the degrees of freedom. Now, how are you going to calculate the degrees of freedom? The degrees of freedom is the number of categories of the first variable, minus 1, times the number of categories for the second variable, minus 1. So looking back at our table, for the first variable, we have 3 categories. For the second variable, we have 3 categories. So the degrees of freedom is equal to 3 minus 1 times 3 minus 1. That is equal to 2 times 2, which is equal to 4. Okay, so your degrees of freedom for this test is 4. With that information, you should be able to find the p-value. Once you find the p-value is going to help you make a decision. If your p-value is less than alpha, equal to 0.05, that's the alpha level we're using here. So if your p-value is less than alpha, equal to 0.05, you're going to reject the null hypothesis. If your p-value is greater than alpha, equal to 0.05, then you're going to fail to reject the null hypothesis. Okay? Once you make a decision, then you're ready to state the conclusion. Again, I'm going to go ahead and let you do this on your own because these are steps that we have taken before when conducting hypothesis testing. We find our p-value, we compare the p-value with our alpha value, we make a decision, and then we write a conclusion. Okay? So go ahead and do this on your own. Now, before I stop this video, let me emphasize how you can expect to see this type of problems on an exam. You're obviously not going to have enough time to do the whole test on your own. For the final exam, for example, we only have 2 hours, so I won't be asking you to run the whole test on your own. What can you expect? Well, you can expect me to say, look, I found the expected value for all the cells except for 1. Can you show me how to find the expected value for this last cell? Same thing with the value of O minus E squared divided by E. I wouldn't expect you to find this value for all the cells. I would give you the values for all the cells except for 1. I would say, can you find O minus E squared divided by E for the last cell here? And then I would say, okay, now that you have all the values for O minus E squared divided by E, can you find your test statistic? Once you have your test statistic, then you should be able to find your p-value, make a decision, and write a conclusion. Okay, so that is how you can expect to see this type of problems on an exam. I do have an activity at the bottom of this module where I give you a problem like the one you would see on an exam. So go ahead and look at the activity. Again, it's going to be under this module.